Hello everyone. Today we will learn motion of a particle in a magnetic field. What will happen if a particle enters in a magnetic field? Suppose this is the magnetic field we are assuming. It is a uniform magnetic field and this field is perpendicular down to the plane of the paper. So this is the representation of the magnetic field. Cross means the field is downward inside the paper. If any particle will enter, suppose this is the particle which has entered into the field. This is the particle Q and its speed is in this direction. So in which direction it will experience the force and in what kind of motion it will take place. So we know the speed will have two components, right? The speed will have two components. One is the parallel to the field. So let me call it parallel to the field. I am showing it like this and it will have a component which is perpendicular to the magnetic field, correct? Because the particle is entering at a random speed v inside the field. So it will, any speed will have two components, okay? So what will happen due to the perpendicular motion, perpendicular speed? So write down due to perpendicular component. So how much force it will experience? It will experience F is equal to Q V cross B, which is nothing but QVB sine theta, and the component is perpendicular to the field. So that means theta is 90 degree. So the magnetic field experienced by the particle will be QVB sine 90. Sine 90 is 1. So force will be basically QVB. And what are the meaning of QVB? Let me write it here. So here Q is the charge of the particle, V is the vertical component of the speed, because we are considering only the vertical component right now. So this much is the force experienced by the particle. And what will be the direction of this force? In that direction that particle will move. So for that we use the cross product rule. If you put your fingers, right hand fingers, in the direction of V, take out your hand and put all of your fingers in the direction of V, and then curl them towards the magnetic field, which will be going downward inside your paper. So here I am trying to show you the direction of force. So we will use right hand thumb rule to find the direction of force. Take out your right hand. The fingers, all the fingers should be in the direction of V, and then you curl them in the direction of B because magnetic field is downward. So where the thumb is showing, there is the direction of force. Okay, so if my V is here, magnetic field is down, so this is the direction of force, because direction of force is given by V cross B. Okay, is given by V cross B. So we have to curl our fingers in, we have to take all the fingers in the direction of B and curl towards B. Okay, take out all the fingers in the direction of B, curl out in direction of B. The force direction will be this. Suppose V, the particle is moving in this direction, V is downward, so thumb will show the direction of force. So here in this, if I curl, the direction of force I feel is here. So because the speed is here and force is here, somewhere will be the resultant. The particle will move somewhere here. The new position of the particle will be here. And the direction of wave is here, always tangent to the direction of path. Okay. This is the speed. And if you put again your hand like this and curl your finger downward, so you will see thumb will be in this direction. You should try it with your own hand. Use only right hand. Use only right hand inward. And the resultant direction will be somewhere in between, and particle will come here. Now new position of particle is this, speed is here. Again you will see the force direction is towards the center. Particle will come here. Again it will experience some force towards the center. Again the tangent speed is here. Magnetic field is downward. Net force will be somewhere towards the center. Okay. Because of that, the particle will take a circular path. Means particle is always experiencing a force which is not allowing it to go straight. It will bring it back, then bring it back, then bring it back. Like this, when the particle is doing, it will start to move on a circular path. I hope you are getting it. You try with your right hand on your own. So, like this, particle will start moving on a circular path. So, this is a very important part of the chapter where the motion of the particle due to the vertical component of speed is nothing but circular motion. Okay. And the point to be noticed is the magnetic force here will work like a centripetal force for the circular motion. So these two are the very important points to be remembered. There is a circular motion and the magnetic force will behave like a centripetal force for this circular motion. Okay. Now we will check what kind of motion will happen due to the parallel component. Okay, because every speed will have two components, parallel component and perpendicular component. The motion due to parallel component, due to parallel component. So whenever we have studied that if the particle's speed is parallel to the field, the magnetic force will be qvb sine theta. And since it is parallel, theta is 0 here. The magnetic force will be F is equal to Q VB sine 0. And sine 0 is 0. The magnetic force due to the parallel component of the particle speed is 0. So it will not experience any force as if there is nothing. Okay, no force means no acceleration and there will be no change in the speed and particle will keep on moving its own original speed. So it is clear, no force means no acceleration means there will be a linear motion along the direction of B with this is initial speed V parallel. Okay. The point to be noted is both motion will exist together. Both motion will exist together. Why? Because the speed with which the particle has entered has both components, V parallel and V perpendicular. Now, because both motions are present together, so what kind of motion they will together that particle will experience will be something like this. If we observe, suppose this is the direction of magnetic field and these are the direction y and z. So because of one perpendicular component, particle will try to go on a circular path. Okay, but due to a linear motion, it will try to go a little bit forward in the direction of B. Then again, it will try to go on a circular path due to vertical component, but linear due to parallel component. And this type of motion will be observed. Okay, and this is called helical path. This type of path is called helical path. So if the field is in the direction of x, the particle will be making a circular motion in the plane which is perpendicular to x, and it will take a little bit linear path forward in the direction of B. The net effect of the motion of the particle will be helical path. This will be the final path of the particle.